We are going to get started here into chapter 12. Chapter 12 is all about surface area and volume. And unfortunately, this is a great chapter that it works to be in person for because there's lots of hands-on things and lots of really fun stuff that I have done in the past and had planned for you. But here we are going to stay optimistic and we're going to make the best of this. And I've got some good things up my sleeve. One big encouragement or one piece that I would encourage you to look at is to make sure that you seek out visual models online for this. I will try to provide as many as possible, but if you're having a hard time wrapping your mind around this unit, make sure you look up visuals of 3D figures because those are going to be really important as we move forward. All right, looking at a blank screen and hearing my voice is probably not the same as doing stuff, so let's get going. So we are going to talk about three-dimensional figures, specifically called polyhedron. So a polyhedron, or the plural of that is a polyhedra, is formally defined as an area of space that is enclosed by polygons. So it's a three-dimensional figure that is made up of polygons. And so if we were in class right now, I would ask you to look around you and think of three-dimensional closed figures that are made of different polygons that you can think of. So hopefully, I assume everyone here is watching this at your house, and so you actually probably have more variety than you might have in the classroom. And so look around. What are different things that you see in your space around you? So for example, I just moved, so I have a ton of boxes, and boxes are a great example of a polyhedron. And specifically today, we are going to talk about prisms and boxes. Rectangular boxes, any sort, are all types of prisms. You can think maybe you are looking in your pantry. There are lots of pantry goods like a can of something that is a great example, or a jar of peanut butter, and those are all examples of polyhedron, so an area of space that is enclosed by different levels of polygons. So today we're going to talk about specifically the prism, and we're going to work just with surface area today. And from my understanding, you have seen some of these formulas before, and so hopefully this will be ringing a bell, maybe bringing up a new idea of this. So here's the idea. A prism is a polyhedron that has two congruent parallel polygon bases. Sorry, that N is extra there. So polygon bases that are joined by parallelograms or rectangles, or often you can think about the fact that it's two parallel congruent bases, and the vertices of those bases are connected by lines that are all parallel to each other. So as we identify the difference between the bases and those sides, so as we look at the triangle here, this is called a triangular prism. So depending on the shapes that are parallel, so in this case we have a triangle that is parallel to another triangle, and those are what we are going to call the bases of these figures. So the bases are whatever polygons that you have that are parallel to each other. With a rectangle, you have a couple more choices. We could say that maybe the top, think of it as a box, like with a lid and a bottom, that maybe those were the parallel sides, or you could have picked the sides in the front and back. Over here, we have a hexagonal prism because we have a hexagon. And with the hexagonal prism, we don't have any options. It has to be the shapes that are congruent and parallel to each other. The only shapes in this that are parallel are the two hexagons. If you notice something, what I want you to pay attention to is the sides that make up this three-dimensional figure for a prism are all going to be either parallelograms, or in our case, we're mainly going to work with right prisms. And in that case, they are all going to be rectangles. So this example I've given below here, oh my goodness, my computer's about to die. Okay, let's keep going. The diagram that I have given you right here is what is called the net of a prism, which is, imagine if I were to take a prism and if I were to cut it open along its seams and lay it flat so that it was one figure, we can see all the pieces that it's made up of. So almost like we're unfolding it so that we could fold it back together. And so if we look at here you can see this idea of our bases, and then the sides that enclose around it. And I think the triangle makes that most evident, where you can kind of picture, to make our shape on the left, we could fold up each of these triangles, and then like a lid, the other triangle off to the side would flip and close to make our shape here. So it takes a little bit of mental, working to figure this out, but hopefully this makes sense. So our bases are the parallel and congruent polygons. They can be any figure. And the lateral faces are the rectangular or parallelogram faces that connect the bases. So we have two key pieces of a prism, and so when it comes to the surface area, and there are going to be two different pieces. The first piece that we're going to talk about is what is called the lateral area. So the lateral area of a right prism, this is going to be the area of all of the lateral sides. So it's the sum of the area of all of the lateral sides. And so if we think about this in real life, if you think about a box, when you set a box down, we've got maybe a lid on the top and we've got the part sitting on the bottom. The lateral sides are going to be each of the edges that are connecting the base on the ground to your lid. And so it's the area of all of those figures. I think of it as like the sides of it, and then we have a base and we have a top. So as we think about this, as we look at our different rectangles, what you can start to figure out is that when we open this up, I'm actually going to consider the two little flaps over here to be my bases. I form a larger rectangle, and specifically for this rectangle, my prism has a specific height, and then the width of that rectangle is going to be the sum of one of the edges of each of these rectangles. But if I think about that, ends up being the perimeter around one of my bases. And so for this formula here, the lateral height of any right prism actually boils down pretty nicely that the lateral area, which we call capital LA, ends up being the perimeter of a base, so the perimeter of whatever polygon is our base, times the height of our prism, which is the distance between our bases. If this feels confusing to you, you also can individually find the area of each rectangle and then add up those areas. But this perimeter times height formula is a great time saver because that's essentially what you end up doing when you find the area of each individually. So for the total surface area, if we think about, all right, the lateral area, I have just found the sides of my box and the total area. And this is just the area on the outside. I think about if I were to put wrapping paper, if I were to cover this just on the outside, how much area am I covering by covering the outside of this box? Total surface area is like including the base and the lid. It includes our bases into this. And so for our symbols over here, we are going to talk about our prism has a total height. That's the distance between from base to base. And then each base has a perimeter. And then we are going to let capital B represent the area of the base. Now, this is important. The formula for B varies depending on the shape. That's why we keep it really general. If it is a rectangle, we can do areas base times height. If it's a triangle, you're going to have to use different triangle methods. Same for other types of polygons. But it boils down to this. The total surface area is going to be the lateral area plus, we want to ask, how many bases does this have? It has two bases, so be plus 2 times the area of the base. And so for our total surface area, that would mean that it will be the perimeter times the height plus 2 times the area of one base. So this is a lot of symbols. Let's look at what happens and how this actually looks in an example. So As I look at this figure, it says find the lateral area and total surface area of the right triangular prism. So here's what you first want to identify. One of the biggest pieces that people struggle with three-dimensional prisms is what are the bases. So think about in this case, what two faces are parallel to each other, and that is the triangle. It's always going to be, if you have a shape that's not a rectangle, those will always be your bases. So I am going to highlight them to make it really clear. Remember that these shapes are congruent and parallel. Another important figure is lengths that correspond. If you were to go across the shape, they're going to be congruent to each other. So if I look at the front base that has sides 10 and 16, I don't know what the third side is, but if I look at this length and I travel down to where it corresponds on the bottom base, they tell me that is 10. So I can fill in that this length here is 10, and this gives us a clue. This triangle is an isosceles triangle. Now, next up, when we talk about height, there can be a variety of heights when it comes to a problem, now that we're working with many shapes. Triangles have heights, other shapes have heights, but when it talks about the height of a prism, the height of the prism is the distance between your two bases, or how long it is between, in this case, our two triangles. So that's going to be the length of any of these sides here. These will all be the same length. And it tells us on this bottom one that it's 18 units. So the height is 18. So now we know a couple of pieces here. So the area, the height is 18. And then the perimeter is not the perimeter of this whole shape, it's the perimeter of one of the triangles. So that is going to be 10 plus 10 plus 16, which gives us a perimeter of 36. And so now for the lateral area is perimeter times height. So that's going to be the perimeter of 36 times the height of 18. And let's see here, that's going to make this, we're doing some cool graphs in pre-calc. That was going to make this 36 times 18, which is 648. And we are working with area, so this is going to be units squared. So the lateral area is 648. And now that we have, did I do that? Yep, okay, perfect. All right, so now that we have calculated the lateral area, in order to find the surface area, the only thing that we need to add in is the area of the bases, which are those two yellow triangles. So all the rectangles, there's 3 of them right now, those combined have an area of 648. So now we need to figure out the area of one of the bases, and we're going to call this capital B. So now, since this is an isosceles triangle, I am going to draw the height into this triangle. Remember, it does cut the base in half, so that makes this 8. And then looking at that right triangle, we could use Pythagorean theorem or recognize the triple, that this is a 3, 4, 5 triangle times 2, so that makes this a height of 6. So the area of my base is 1/2 of the triangle height of 6 times the base of 16. And so that makes this, I'm going to cut 16 in half so we can do this in our head. So that makes this 6 times 8, which is 48. So now our total surface area is going to be the lateral area. So the area combined of our 3 rectangles along the side, 648, plus 2 times the area of one of the bases, which is 2 times 48. So then now that gives us, plus 2 times 48, that gives us 744 square units of area. So let's say this was inches, and the question was how much wrapping paper would it take to cover this? It would take total 644 square inches, 744 square inches of wrapping paper to cover this. All right, next up, number 2. Let's look at find the base of a regular hexagonal prism. the base of a regular hexagonal prism has a side length of 8. If the height of the prism is 12, find the lateral surface area of the prism. Now, here is one of the trickier parts. We want to draw a prism. Here's what I want you to think about. One of the easiest ways to do it is to draw a hexagon, but smush it. So let's see if I can do this. So the base is a hexagon. It did not like that. Okay, so we'll go it one by one. So we're going to draw a smushed hexagon where the sides look approximately the same length. And then what you can do is you can start drawing some sides down from here. And actually what I often do, this is the little trick, is you can copy the base and slide it down and then start connecting. And ta-da! We have ourselves a pretty good prism. Okay, all right. Those back lines are confusing me, so I'm going to leave them out. Okay, so we've got a hexagonal prism, and the base each has a side length of 8. And it's regular, so we can assume that all lengths are congruent. It says the height of the prism is 12. What that means is all of these vertical lines we drew in are all going to be 12 units long, and all of these faces are going to be, all of these lateral faces here will be 8 by 12 rectangles. So as we start to figure this out, it asks us to find the lateral area and the total surface area. So the first thing for lateral area is we need to know the perimeter of our base. So for a hexagon, if it's regular, all sides are congruent and they're all 8 units long. And so the perimeter, we have 6 sides that are all 8 units long. It's a perimeter of 48. And the height is 12. So that makes our lateral area of this come out to be 48 times 12, which gives us a lateral area of 576 square units. All right, so hopefully that part didn't seem too crazy. Now we need to figure out the area of one of these hexagons, and then we'll multiply it by 2. So remember, for a hexagon, let's see if it will take this. All right, not bad. Okay, remember that for a hexagon, we can find this in an exact form. There's a couple of different ways to do it. If this has a side length of 8, remember that a hexagon specifically divides it into equilateral triangles, and there are 6 of them. So if I figure out, sorry, did some scrolling on me. If I figure out the area of one of these triangles, I can multiply them by 6, or you can use 30, 60, 90 triangles. It's up to you from there. I'm actually going to figure out my apothem. This is 60. This is 4. That makes my apothem come out to be 4 root 3. So for the area, this would be 1/2 of the apothem of 4 root 3. And then we actually already found perimeter. So the perimeter is 48. And so then multiply that, the 4 root 3 times 48, divide by 2. That would make this 96 root 3. Just double check that because it's kind of late for it. Yeah, 96 root 3. Awesome. Okay. So then now for our total surface area, we'll take the lateral area that we found of 576, and then we'll add 2 of our bases. So 2 times 96 root 3 makes this 576 plus 2 times 96 root 3. So if you want to put this in a rounded approximated form, this would be to the nearest 10 908.6. 908.6 square units. Or if we want to leave it in exact form, this is 576 plus 192 root 3. Either way, it doesn't specify there, and so that would be our correct answer for our total surface area, either in rounded or exact form. We're going to look at one more here. Hopefully this is starting to make more sense. There is so many good resources out there on the internet about lateral surface area and surface area of prisms. So if you would like some more explanation, go look up Khan Academy videos, search on YouTube. There's lots of good stuff out there. All right, last one, and then this next one will be extra if you want to look at the final answers. Okay, the base of a right prism is an isosceles trapezoid. So now we can picture that we have some sort of isosceles trapezoid, and then we're going to connect those sides. Okay. Alrighty. And then we'll draw, sometimes I'll draw it at an angle just so that we get a better picture of it. This is not my best. Okay. This one's not my best that I've ever drawn. Takes some time to get used to. Alrighty. Whew, this is bad. Okay. Oof, I gotta cut this out. This is terrible. Okay. We're gonna restart this problem. We're gonna restart it now. All right, so for number 3, we have another right prism, and it tells us the base of the right prism is an isosceles trapezoid with sides 10, 7, 10, and 17. Tells us the height of the prism is 8. Find the lateral area. Find the total surface area. All right, so let's draw an isosceles trapezoid that's a little bit smushed. All right, it's a little bit off, but that will work. I'm going to copy and paste it, and then connect my sides. And there we have it. Okay, so this is we've got 4 different rectangles here, and this is our shape. And so then it tells us that we have legs of 10, 10, and 7, and then a base of 17. So remember, for the lateral area, we need to find the perimeter of our base times the height of our prism, and it tells us the height of the prism is 8. So all of these sides have a length of 8 that are connecting between our bases. And so for our perimeter, we have side 17, 17, 10, and 10. When we add that up, that should give us 20 plus 24, which is 44. So we have a perimeter of 44, and then times our height of 8. And then we can calculate our lateral surface area, multiplying those together to get 352. So that is our lateral surface area. Again, I don't think I have reiterated this enough. If you are having a hard time comprehending this, you can also calculate the area of each rectangle. For example, the rectangle over here on the right has a bottom of 10 and a height of 8. It would have a height of 80. The rectangle in the back has a width of 7, height of 8. That would make its area 56. This would also be 80, and then the one, highlighter out, the one in the front, this guy right here in the front, has a base of 17 and a height of 8, which would be, oh my, we're doing some late math here. Get the calculator off for that one. 136. So it would be 136 for the front base. You could also add those up together to get 352. So that is another option if this is just not clicking for you. Okay, so we've got our lateral area. Now we need to figure out the area of this base. So this base, it always is specific to what shape you have. So this is a trapezoid. So remember, our formula is 1/2 base 1 plus base 2 times the height. The height in this case, we want to be careful, is not the height of the prism, it's the height of the trapezoid. So h is going to come up in different cases, and we want to make sure that we're using the right one. So for our trapezoid, then now hopefully you know how to find this. I'd encourage you, pause the video, stop, find the height on your own, and then check with me and check back in from here. But as we go to solve this middle part is 7. That means we have 10 units to split between, so that would make this 5. And then with Pythagorean theorem, that makes this 5 squared plus h squared equals 10 squared, so 25 plus h squared equals 100. That gives us h squared is 75, and that is 75 is 25 times 3, so this comes out to be the square root of 75, or 5 root 3. So going back here, that would make this base 1 plus base 2 is 7 plus 17, which is 24. So half of 24 times 5 root 3. And then we have half of 24 is 12. And then 12 times 5 is 60. So that would make the area of one base 60 root 3. So then in total for our surface area, this would be our lateral area, which is 352 plus 2 times our base area of 60 root 3, which in exact form comes about to be 352 plus 120 square root 3. And this is in square units. Alrighty, so go on to the practice set. Remember now, the way that we are splitting this up with our new schedule, there are going to be 2 sections, and so for today, so there is another section which is 12.2, which is surface area of pyramids, and then a practice set. If you don't want to do both in one day, then you can split your math into different days. I have broken it up into part A, part B, but everything that was assigned today, because you are everything that was assigned this day will be due the next time we meet. So if you are an odd period, it's Wednesday, yours will be due Monday. If you're a even period and you're watching this on Thursday, then this will be due for you on Tuesday when we meet next. Alrighty. So then up next is the practice for 12.1, and then after that would be the 12.2 video and practice.